A small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Clarus. We are top on the Everest. Congratulations.
I want to be a leader.
Hi Sweros, good afternoon to everybody. This is G. Srikant Swero from JP Nagar, Narkal district. So friends, today I am here to explain an interesting topic to you. Before going to discuss our topic, I would like to ask some question. Shall I? Okay. Friends, do you know what is this? Yes, this is an LED bulb. Yes friends, this is an LED bulb. Then how does it glow? Yes, with the help of current. Friends, now I am taking this LED bulb and connecting to this battery. Let us observe what happens. What you observe, Sweros? What you observe, Sweros? Yes, the LED is glowing. Friends, do you know why the LED is glowing when I am connecting to this battery? Yes friends, due to presence of current. Then what is current? Yes friends, you are absolutely right. Current is a flow of charges passed through the given cross section area of a conductor in unit time. This is called current. Friends, do you know what is electricity? Yes friends, electricity is a form of energy through the given cross section area of a conductor is called electricity. Friends, is there any difference between electricity and current? Yes friends, current is a flow of charges, but electricity is a form of energy. This is called electricity. Friends, now we have a clear idea about what is electricity and what is current. Friends, see here, here is a glorious experiment. Do you know what is this? Yes friends, this is an iron nail. Do you know what are these? Yes friends, these are iron pins. Friends, now I am taking this iron nail and pushing toward these iron pins. Let us observe what happens. See friends, now I am moving this iron nail toward these iron pins. Let us observe what happens. What you observe, Sweros? Yes, there is no attraction between this iron nail and these iron pins. Friends, now can you identify this? Yes friends, this is a magnet. Friends, now I am taking this magnet and moving toward these iron pins. Let us observe what happens. Wow, what you observe, Sweros? What you observe? Yes, the iron pins are attracted to this magnet. Friends, do you know why the iron pins are attracted to this magnet? Yes friends, you are absolutely right. Yes, I know you are a genius. Due to magnetism. Then what is magnetism? Yes friends, magnetism is a class of physical phenomena that are mediated by magnetic fields. Electric currents and magnetic movements are elementary particles that gives rise to magnetic field. This is called magnetism. Spheros, now I am taking this nail and winding with a copper wire. A wound iron nail is ready. Now I am taking this wound iron nail toward these iron pins. Let us observe what happens. What you observe, Spheros? Are the iron pins are attracted to this wound nail? No. Friends, now I am taking this wound iron nail and connecting to a battery, and again I am taking this wound iron nail toward these iron pins. Now I am connecting this wound iron nail to a battery. Spheros, now this wound iron nail is connected to a battery. Now I am taking this wound iron nail towards the iron pins. Let us observe what happens. What do you observe, Spheros? Yes, the iron pins are attracted. Friends, when I am connected battery to this wound iron nail, or the iron pins are attracted. Friends, do you know why the iron pins are attracted? Even there is no magnet. Okay, let me explain. Friends, when I connected a battery to that wound iron nail, electric current passed through the terminals of the copper coil to that wound iron nail and gets energized and acts as an electromagnet. So friends, this process is known as electromagnetism. Exactly friends, today we are going to learn about electromagnetism. What is electromagnetism? Electromagnetism. Spheros, how many of you have heard about what is electromagnetism? Do you know what is electromagnetism? Yes friends, you are absolutely right. It is a branch of physics. It deals with the electricity and magnetism. It is a physical interaction between charged particles. Usually electromagnetism force exhibits electric field and magnetic field, and electromagnetic force is one of the fundamental forces in nature. This is called electromagnetism. Friends, initially scientists believed that electricity and magnetism were different phenomena, but in 19th century this view was changed. The great scientist IIyr proved that there is a relation between electricity and magnetism. Friends, just now we have learned that electricity and magnetism were interrelated, and moving electric charges produce electric current. Friends, tell me now, can moving magnets produce electric current? Yes friends, it's possible. The experiment of Michael Faraday in England and Joseph Henry in USA were demonstrated that electric current were induced in the closed coils when subjected to the changing magnetic field. The phenomena in which electric current is induced by the moving magnets, and that process is known as electromagnetic induction. Friends, let us understand what is electromagnetic induction with a simple experiment. Friends, do you know what is this? Yes friends, what is this? Yes, this is a center zero galvanometer. Then what is the use? Yes friends, it detects the currents. Friends, do you know what is this? Yes, this is a magnet. Friends, see here, this is a copper coil, and this copper coil is connected to the galvanometer internally. Friends, now I am taking this magnet and I am pushing this magnet into the coil. Let us observe what happens. What you observe, Sweros? What you observe, Sweros? Yes, the pointer in the galvanometer shows deflection. Friends, now again I am taking this magnet out of the coil. Let us observe what happens. See friends, now I am taking out of the magnet out of the coil. Let us observe what happens. What you observe, Sweros? Yes, you are absolutely right. There is a deflection in the galvanometer, but it is in opposite direction. Friends, do you know why the galvanometer is showing deflection? Is there any mechanism behind this? Yes friends, due to the presence of electric current in this coil. The presence of electric current due to the, when I am pushing this magnet and pulling this magnet away from the coil, and electric current is induced in this coil. Friends, again I am taking this magnet and changing the polarity of this magnet, and again I am pushing this magnet into the coil. Let us observe what happens. Sweros, now I am pushing this magnet into the coil by changing the polarity of this magnet. What happens? Let us observe. What you observe, Sweros? Yes, there is a deflection in the galvanometer. Friends, now I am taking this magnet out of the coil. Let us observe what happens. What you observe, Sweros? Yes, there is deflection in the galvanometer, but it is in opposite direction to the previous case. Friends, do you know why the galvanometer is showing deflection? Yes, you are absolutely right, friends. When I am pushing this magnet into the coil and out of the coil, an induced EMF is producing in this coil. Friends, now I am keeping this magnet stationary in this coil. Let us observe what happens. Friends, now this magnet is in stationary position in the coil. Is the galvanometer is showing any deflection? No, the galvanometer does not showing any deflection. Friends, by this we can conclude that when the magnet is stationary, the galvanometer does not show any deflection. Sweros, now I am moving this magnet up and down in the coil. What happens? Let us observe. Let us observe, friends. What you observe, friends? Yes, the galvanometer is showing deflection. Friends, by this we can conclude when the magnet is in motion, the galvanometer shows deflection. Sweros, now I am pushing this magnet into the coil and pulling this magnet out of the coil fastly. Let us observe what happens. See friends, now I am pushing this magnet into the coil and pulling this magnet out of the coil. Let us observe what happens. What you observe, Sweros? Yes, the LED is glowing. Friends, now I am taking this magnet and changing the polarity of this magnet. What happens? Let us observe. See friends, now I am pushing this magnet into the coil and pulling this magnet out of the coil fastly. Let us observe what happens. What you observe, Sweros? What you observe? Yes, the another bulb is glowing. Friends, do you know why the bulbs are glowing? When I am pushing this magnet into the coil and pulling this magnet out of the coil fastly? Yes, yes friends, you are absolutely right. Due to the presence of electric current in this coil, that's why the two LED bulbs are glowing. Friends, let me know why the bulbs are glowing. Yes friends, due to the presence of electric current. Then how it is producing? Yes Varos, when the magnet is in motion, that's why an EMF inducing in the coil. That's why electric current is producing in the coil. So the LED bulbs are glowing. Friends, do you know what happens when the magnet is in motion? Yes, absolutely right. When the magnet is in motion, there is a magnetic flux change in that coil. Then what is magnetic flux? Okay, let me explain. Magnetic flux means number of flux lines pass through the given area of a conductor. If vector B is the magnetic field and vector A is the effective area of a conductor, when exposed to magnetic field, then magnetic flux phi is equals to vector B dot vector A, that equals to BA cos theta. Friends, let us understand what is magnetic flux with the help of a simple diagram. Magnetic flux means number of flux lines. Friends, these are the number of flux lines, that is vector B, and these flux lines pass through the given area of a conductor. Friends, this is the area of a conductor, that is vector A. Friends, the product of vector B and vector A is called magnetic flux. Then magnetic flux phi is equals to vector B dot vector A, that equals to BA cos theta. Friends, do you know what indicates this theta? Yes, theta is the angle between vector B and vector A. Vector B and vector A. Friends, do you know what is the SI unit of magnetic flux? Okay friends, SI unit of magnetic flux is Weber. The SI unit of magnetic flux is Weber. The SI unit of magnetic flux is Weber. Friends, this is magnetic flux. Let us come to our experiment. Friends, when I am pushing this magnet into the coil, the distance between the magnet and the coil is vector B, that is magnetic field. This area is known as effective area of a given conductor, that is vector A. The product of vector B and vector A is called magnetic flux. This is called magnetic flux. Friends, now I am pushing this magnet into the coil, the rate flux is increased. When I am pushing this magnet into the coil, the rate flux will increases. When I am pushing this magnet out of the coil, the rate flux will decreases. Whereas whenever there is a flux change with respect to time, an induced EMF, electromotive force, induced in that coil. Therefore, the rate of flux change is directly proportional to induced EMF. Then induced EMF is equals to minus n d pi by d theta. friends, is here n is the number of turns in the coil, that epsilon EMF epsilon is equals to minus n d pi by d theta. Friends, here minus sign indicates the epsilon opposes the flux change. Friends, this law is known as Faraday law of electromagnetic induction. Friends, now we have a clear idea about what is electromagnetic induction. Then what is the use of this principle? Is there any advantages in our day-to-day life? Yes, friends, whatever we use power devices in our homes and office, from table fans to microwave ovens, there is some form of electromagnetism in their functioning. Friends, let us see the bulbs in your rooms or in your hostels. Are you able to see without that bulb? No, it's impossible, because light is an electromagnetic wave that is also works under the principle of electromagnetism. Friends, let us observe moving rotating electric fan that is in your room or that is in your dormitories. Do you know that electric fan is also works under the principle of electromagnetism? Friends, see this mic. Even this mic is also works under the principle of electromagnetism. Friends, if cameraman will stop telecasting my teaching, are you able to see me? Are you able to see my teaching? No, it's impossible. Even that camera is also works with the principle of electromagnetism. Then what are the electronic devices that does not work with the principle of electromagnetism? No, all the electronic devices that we use in our day-to-day life, that comes under the principle of electromagnetism. Friends, for instance, computers, televisions, loudspeakers, DVD players are the examples of electromagnetism in our day-to-day life. Let us understand how electromagnetism employed in our day-to-day life. Friends, if someone wants to meet you at your home, if the house door was closed and you are busy with your work inside in your room, and he is waiting for a long time in front of your door, then how can he consult? What can he use? Yes, friends, electric calling bell. Do you know even electric calling bell is also works with the principle of electromagnetism? Yes, friends, I have a model of electric calling bell that works under the principle of electromagnetism. Let me show you. Friends, this is a model of an electric calling bell that is made by me. Friends, see this is a tap key, and this is a battery, and this is a metallic glass, and this is a motor. Friends, now I am switch on this tap key. What happens? Let us observe. What you observe, Feroz? Yes, sound is producing. Do you know why the sound is producing when I am switch on this tap key? Is there any mechanism behind this? Yes, friends, your assumption is correct. Friends, inside this motor, the structure is like this. This is a soft iron rod, and these two are the permanent magnets. This soft iron rod is arranged between two permanent magnetic poles, and this soft iron rod is bound by a copper coil, copper wire, and the soft iron rod is arranged between the two magnetic poles. When electric current is received this motor, this soft iron rod gets energized and rotates itself by hitting this glass. That's why the sound is producing. Friends, this is the one of the application of electromagnetism that we use in our day-to-day life. Friends, this is easy to made in our schools, in our dormitories, to prove our talents in front of dice. Friends, this is one of the application in our day-to-day life that works under the principle of electromagnetism. Okay friends, let us come to next application. Friends, if there is no power in big commercial complexes like meeting halls, cinema theaters, etc., what do they use? Yes friends, generators. Do you know even generators also works with the principle of electromagnetism? Yes, then what is generator? Absolutely right. Generator is a device which converts mechanical energy into electrical energy. Friends, I have a model of a generator that works with the principle of electromagnetism. Let me show you. Friends, this is a model of a simple generator. This is a wheel that is attached to this soft iron rod, and this soft iron rod is placed between the two permanent magnet poles, and this soft iron rod is bound by a copper wire. See friends, now I am rotating this wheel. What happens? Let us observe. What you observe, Feroz? Yes, the LED light is glowing. Friends, do you know why the light is glowing when I am spinning this wheel? Is there any mechanism behind this? Yes friends, let me explain. Friends, when I am spinning this wheel, the soft iron rod which is arranged between the two permanent magnet poles, this soft iron rod is gets energized and acts as a electromagnet, and here this soft iron rod produces electric current to this LED. That's why the LED is glowing. This is a simple generator that works with the principle of electromagnetism. This is one of the application of electromagnetism. Friends, not only this, there are plenty of advantages in our day-to-day life by the principle of electromagnetism. Let us understand with the help of PPT. Friends, if electromagnetism disappear, what happens? Can you assume? Can TV will work? Can camera will telecast my teaching? No. Can mobile, can telephone can work? No, it's impossible. So let us understand the importance of electromagnetism with the help of PPT. Friends, electromagnetism employed in transportation. Let us understand how electromagnetism is employed in transportation. Friends, have you heard about bullet train? Let us see with the help of simple short. Friends, do you know what are these? What is this technology? Recently, our Prime Minister inaugurated in other state. Recently, he visited to other countries. Friends, this is the modern technology of transport system. that use the concept of electromagnetism. Friends, these are also called high speed trains, which use powerful electromagnets to develop the speeds. Friends, this train will float over a guideway by using basic principles such as electromagnetic suspension and electrodynamic suspension. Friends, in electromagnetic suspension, electromagnets are implied on the body of the train that are attracted to the rails. The electromagnets wrap around the round and attractive force between the guided ways and magnetic fields makes the train forward. And in EDS, nothing but electrodynamic suspension, the train is alleviated by the repulsive force between the magnetic fields and guided rails by the induced currents. When electromagnets gets energized, the train will be alleviated by the attractive force between the magnetic fields and coils. Friends, let us see how the train will be alleviated in that coil. See friends, he is putting the what you observe, Veros? How the train is moving? With a high speed, the train is moving compared to the normal trains without interaction, without electricity. Friends, this is the one of the applications that we use in daily life. Let us come to our next application. Friends, just now we see that how electromagnetism is employed in bullet trains. Let us understand in other field. Friends, electromagnetism is employed in daily life. Whatever we use power devices in our homes, in our offices, there is some form of electromagnetism in their functioning, such as moving electric fan, loudspeakers, DVD players and televisions, video cassette recorder, video cassette player and so on. These are the examples of electromagnetism in daily life. Now, electromagnetism in other field. Electromagnetism in medical field, such as human body communication, brain stimulation, MRI scans, X-rays, CT scan. Friends, do you know what is MRI scan? Yes friends, MRI scans a key role in medical field. Usually MRI scan is a medical imaging technique that use the radiology to form the pictures of the anatomy, and it is useful for physiology process of the body in both health and disease. MRI is widely used in hospitals, clinics for medical diagnosis. Friends, MRI is widely used in to picture the every part of the body, and it is especially useful for neurological conditions such as disorders of the mental muscles and joints, and evaluating the tumors and so on. This is the one of the applications of electromagnetism that will works in our day-to-day life. Let us comes to in another field how electromagnetism is employed. See friends, electromagnetism in transportation, that is bullet train, driverless car. Friends, can you imagine how car is drive without a driver? Yes, it is possible. Future, it is possible by the using of electromagnetic principle. And electromagnetism in transportation, jet planes, EM propulsion, and in another field, electromagnetism in civil engineering, such as electromagnetism in distance measurement, such as microwave, infrared EDM, measuring difference height, setting out distance. These are the examples of electromagnetism in civil engineering. Now next, electromagnetism in science and technology, such as scientific instruments such as particle accelerator, that is cyclotron, solenoid and a toroid. Friends, do you know what is cyclotron? What is the use of cyclotron? How it will works by the principle of electromagnetism? Okay, let me explain. Cyclotron is a particle accelerator by using high frequency alternate current, and that is placed between the two hollow shaped D-shaped hollow shaped. See friends, how cyclotron works with the help of short video clip. Let us see. Friends, these days electromagnetism plays a crucial role in our day-to-day life. Let us observe how cyclotron works with the principle of electromagnetism. Friends, this is a cyclotron. Let us observe how cyclotron works with the principle of electromagnetism. Friends, the arrow marks are revolving in the cyclotron, and induced EMF is revolving around the cyclotron. That the direction B is the direction of induced EMF. Let us see friends how cyclotron works with the principle of electromagnetism. Friends, just now we see that how cyclotron works with the principle of electromagnetism. Next, electromagnetism in defense, such as railgun technology, that is nothing but super weapons and plasma rifle, launch pad, catapult. Do you know what is catapult? Yes friends, gulliver, that is we used to hunt the birds or hunt any something. And invisible machines, magnetic flowering technology and space technology and pulse technology. Friends, do you know what is railgun technology? Yes friends, railgun is a weapon, that is a electromagnetic projectile launcher. Friends, a railgun can take enormous power to fire. Railgun is being researched as a weapon. Friends, a railgun can destroy an enemy even he is 100 miles away, and a railgun bullets fires 8 times the speed of the sound. Friends, this is the railgun technology. Let us understand how railgun technology works with the principle of electromagnetism with a short video clip. Friends, this is a railgun technology that works with the principle of electromagnetism. See friends, how railgun will works with the principle of electromagnetism. Now a railgun is fired a bullet. See how fast it is going. It is the 8 times the speed of the sound. Can you imagine that? No, it's highly impossible. We cannot imagine that much of sound. Okay friends, now next field, friends, these are the applications of electromagnetism. Let us know how electromagnetism in another field. Electromagnetism in communication system, such as electromagnetism in radar, antennas, sensors, microelectromagnetic mechanical systems, motors and powers, generators and transmissions, and transmission of energy by electromagnetic waves in mobile communication. See friends,
Hello?
hi Swero. Hello Swero.
Hello?
Hello Swero, how are you?
Hi, Swaro.
Hi.
This is Shani Swaro, Matanpalli, Surapeta district.
Okay Swero, tell me your doubt.
My question is, what happens to the mechanical energy when a conductor is moved in a uniform magnetic field?
Will you repeat again?
What happens to the mechanical energy when a conductor is moved in a uniform magnetic field?
Wow, nice question friend. Sorry friend, I have no answer, but I consult with my teacher and discuss with you later again. Okay friend? Friends, see this picture that is captured by a radar. This picture is our earth by capture of a radar. Okay friends, what we have learnt in this section. Hi Swero. Hello Swero.
Hello, Sparrow. In daily life, why we are not using induced current?
In daily life,
Why we are not using induced current?
induced current. Induced current. Hello friends, let us understand what we have learned in this session. That is, what is electromagnetism and how Faraday law established relation between induced EMF and magnetic flux, and what are the applications of electromagnetism. We have learned that friends, these are the applications of electromagnetism that we use in our day to day life. See friends, if
Hello?
Hello Swero.
Hello, Swaro.
Hello Swero, tell me your doubt.
Hi, Swaro.
Hi, how are you?
Hi, I'm Indupriya Swaro from JAM. Swaro, I'm Indupriya from JAM. I have one question. I have one doubt.
Okay Swero, please tell me your doubt.
What is induction and the self-induction? Give me examples.
What is induction? Hello?
Induction and the self-induction. What is induction and the self-induction?
What is induction and self-induction? Friends, induction means current is produced by itself, that is called induction, and self-induction means a current is produced by itself without any interaction between physical interaction between thing and a or conductor. Okay friends, if electromagnetism is disappear, can you imagine the future? Can television will work? Can loudspeaker will work? Can cameraman will telecast my teaching? No. Let us imagine what is the importance of electromagnetism in our day-to-day life. If electromagnetism is disappeared, we can truly return to our dark ages. Yes friends, this is my class, and I will thank to my beloved secretary to providing these kind of programs to prove our talents in front of DICE, and I am thankful for to my teachers, especially to my Prakasham Shetty sir, JL Physics, and my principal, and my teachers and my friends, and CM KCR K Chandrasekhar Rao sir. I am very thankful to provide these kind of programs. Thank you, Sveros, and all the best for your Ajim Premji universities, and all the best for your future. Thank you, Sveros. Bye.